Hi guys, I hope you all are doing well. So today we are going to learn a topic called functions, which is very important and very interesting. So let's learn. Okay. Let's say you have a juicer. Okay. This is a very classic example that I give to each and every student of mine. Let's say you have a juicer. Okay. If you put mangoes inside it, if you put mangoes inside the juicer, what do you get? What do you get? You get mango juice, right? That's so obvious. You get mango juice, right? If you put apples into it, what do you get? You get apple juice. Right? So the things which you are putting inside the juicer, right? The input over here, mangoes and apples, the input, these are known as domain. This is known as domain, right? So domain is nothing but things that can go inside the function, things which are allowed to go inside a function, right? And what are these? Apple juice and mango juice are your output, right? Apple juice and mango juice are your output. This is known as range. Okay. And the thing which is converting your domain to a range, the thing which is processing your input to an output is known as a function. This is your function. Okay. This is your function. I hope you got it. So generally, domain is represented by X, range is represented by Y. And how do we write a function? We say that Y, the output is nothing but a function in X. So it's not necessary that always you will get fx. Someone might write g of x, h of x, r of x, o of x, m of x, anything, right? But generally, this is how we usually define function. Okay. So now there are two more things that I've added here. One is domain, one is range. What do I mean by domain? What do you mean by range? It's very important you know it. So what do you mean by domain? So domain of a function is nothing but set of values that X can have in that function. Okay. So set of values X can take or X can have, whatever you want to write. Okay. For example, let's say you have a function y equal to x square. So what all values are allowed inside X? Okay. So inside X, right? Can I write -4? Yes. Can I write -2? Yes. Can I write -1? Yes. Inside X, can I substitute 1, 2, 3, 4, 5? All these numbers? Yes. So if you observe here, there is no restriction on X, right? So you can say that the domain here is all real. Okay. Also represented by R. So the domain is set of values that X can take. What I mean to say is, let's say I'll give you one more example. Let's say fx is equal to sine x. Now, what all values are allowed for x? All the values you can substitute: -10, -9, -8, -7, -6, -5, -4, -3, -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 crore, 2 crore, 1 million, 2 billion. Anything, buddy, anything. You can substitute anything inside X. Right? So again, the domain over here is all real. All real numbers. Now let me give you a very interesting example. Let's say you have fx equal to square root of x minus 4. Now what is the domain? So what all values X can take here? Can X take a value of 3? Can it take a value of 2? Can X be 1? Can X be 0? No, they can't, right? Because now X has a restriction. What is the restriction? The restriction is, under the square root, you can only have non-negative numbers. Under the square root, only non-negative numbers are allowed, which simply means that X minus 4 has to be greater than or equal to 0. So X will be greater than equal to 4. So what is X? X is anything from 4 to infinity. You never include the value of infinity. That's why you use a round bracket. Over here, the value of 4 is also included. That's why you're using a square bracket. So if you have to include something, if you have to use equality, you use a square bracket. If you have to leave that particular value from the domain or the range, you use a round bracket. Okay. So this is how you write it. So what is the domain of the function? X greater than equal to 4, or you can say x is going from 4 till infinity. So that's the domain. So domain is nothing but set of values that x can take. What is range? What is range? Okay. Now what is a range? What is range? So guys, range is nothing but the set of values y can take. What is range? Set of values y can take. Okay. For example, let's say you have a function y equal to sine x. What is the range of this function? What are the values that y can take? So let's graph this function. On Desmos, and then we'll see what happens. So yeah, y equal to sine x. Now if you observe over here, for the entire graph, the maximum value over here is pi by 2 comma 1. The maximum value, the y value that we are having. Okay, if you want, I'll probably take a screenshot and then edit over it. Okay, yeah. So if you observe carefully, this is the maximum value, right? This is the maximum value. And what is this value? This value is 1. And if you observe, you have a minimum value as well. Right? What is this minimum value? This minimum value is -1. So your function is restricted between -1 and 1. In that range. Okay. So what is the range? The range is -1 to 1. The range is -1 to 1. Okay. So I hope you got it. I hope you got this. I'll write it here. So what is the range over here? The range is y is the least value of y is -1. The maximum value of y is 1. So y is restricted between -1 to 1. Or you can write it as -1 and 1. Both the values are included. That's why you use square brackets. Okay. So this is the range. Now let's say I have one more example. Let's say you have y equal to x square. Now how does the graph look like? If you draw the graph on Desmos, it will look something like this. It will look something like a parabola. This is your y-axis, this is your x-axis. Now if you observe, what is the least possible value of y? The least possible value is 0. And what is the maximum value? The thing is going up. And up, right? So the maximum value could be infinity. Right? So what is the range over here? What is the range for this function? Y is less than infinity and it is greater than equal to 0. So you can also write this as 0, infinity. Okay, infinity is not included, that's why a round bracket. 0 is included, that's why a square bracket, right? So this is how you find the range. So x is domain, y is range. So the set of values x can take is domain, set of values that y can take is range. Don't worry, I'm going to record one more video where I'm going to explain how to find domain and range. Okay, so very important for all the IB kids, IG kids, and everyone who is in grade 11 and 12, right? This topic comes for sure. So this is very important. So I hope you understood what is domain. I hope you understood what is a range. Okay. Now, there is something very interesting that I wanted to discuss. I'm giving you 4 options and then I'm going to ask you a question. Let me draw those 4 options. This is your x, this is your y. This is your x, this is your y. Option number C. X and y. Option number D. X. Okay. So I have a circle in the first option. I have a curve in the second option. Then I have something like this in the third option, and I have something like that in the fourth option. Now you have 4 graphs, right? You have 4 graphs. Okay, before we discuss this, there is a small thing that I wanted to teach you. Let's say if you have x square minus 4x plus 3, what do you call it? You call this as an expression. Okay, now let's say you have x square minus 4x plus 3 equal to 0. equal to 0. What do you call this? What do you call this? You call it as an equation. You call it as an equation. And let's say if you have x square minus 4x plus 3 equal to y, you have equated this time it to some variable. What is this? This is a function. This is a function. So this is the basic difference between an expression, equation and a function. This is a basic difference between an expression, equation and function, right? Always remember that any function can be drawn on the graph. Any function that you're going to study in your entire career, you will be able to draw it on the graph. You will be able to draw it on the graph. Okay. So similarly, I have 4 functions which I have drawn on the graph. You have to tell me which one is function and which one is not a function. You have to tell me which one is function, which one is not a function. So to do this, you have to do something we call as vertical line test. You have to do vertical line test. What do you mean by vertical line test, guys? Draw a vertical line anywhere randomly on the graph. Okay. I get 2 point of intersections in the first part. If you do it for the second B part, I get 1 point of intersection. You can draw this vertical line anywhere on the graph, right? If I do it for the C part, I again get only 1 point of intersection. If I do it for the D part, let's say I do it here, I'm getting 1, 2 and 3 points of intersection, 3 points of intersections. So what do I conclude? Here? If you have only 1 and 1 point of intersection, if you have 1 and only 1 point of intersection, it is a function. If you have more than 1 point of intersections, it's not a function. So guys, this is a function. But what about this? This is not a function. This is also not a function, right? So what does the vertical line test say? Draw a vertical line anywhere on the graph. If you get 1 and only 1 point of intersection, then it's a function, else it is not a function. Okay. So that's how you check if it's a function or not, using a vertical line test. So what do I call it? If you want, I can write it down. You call it as vertical line test. Okay. So this is how you do it. This is how you check if it's a function or not. I hope you understood it. Now I'm going to teach you something very interesting. Let's say you have y equal to f of x, which is such that fx is equal to x square minus 4x plus 3. Someone asks you to find the value of f of 0. How do you find it? Instead of x, you substitute 0. In place of x, you substitute 0. So what will be f of 0? It will be 0 square minus 4 times 0 plus 3. So 0 square is 0, 4 times 0 is also 0, plus 3 is 3. So the answer is 3. What is f of 1? F of 1 will be 1 square minus 4 times 1 plus 3. What I have done here, instead of x, I have substituted 1. So yeah. So what is f of 1? 1 minus 4 plus 3 minus 3 plus 3, which is equal to 0. This is f of 1. Now I'm asking you, what is f of a? So instead of x, in place of x, you will substitute a. So what do you get? A square minus 4a plus 3. Now this time I'm asking you, what is f of fx? So what will you do? In place of x, you will substitute fx. So you get fx whole square minus 4 times fx plus 3. Fx whole square minus 4 times fx plus 3. But if you observe, fx is a function in itself. So what does this become? This becomes x square minus 4x plus 3. I'm substituting the value of fx over here. So this is whole square minus 4 times x square minus 4x plus 3. Okay. And then you had this 3 remaining. So plus 3. plus 3. So what is this? This is known as a composite function. This type of function is known as composite function. Composite function. Okay, very easy. Okay, very, very easy. I'll give you a few more examples. Let's say you have fx equal to sin x, and let's say you have gx equal to x square, or let's say gx is equal to e power x. Okay, now I'm going to ask you, what is f of fx? What is f of fx? What is f of fx? So guys, fx is sin x, fx is sin x. Instead of x, you have to substitute fx. In place of x, you have to substitute fx. So this becomes sin of fx. Sin of fx. What did I do? What did I do? I'll do it again. I'll do it again. Someone asked me to find f of fx. F of fx, right? So I have to substitute fx inside f. I have to substitute fx inside f. So how do I do it? How do I do it? So I have fx. Fx is sin x. Fx is sin x. Now in place of x, I'll substitute fx. In place of x, I'll substitute fx, right? So the answer that I'm getting is f of fx equal to sin of fx. Sin of fx. Sin of fx. But what is fx? What is fx? Fx is sin x. Fx is sin x. So the answer will be sin of sin x. Sin of sin x. Now instead of fx, I have substituted the main function. Instead of fx, I have substituted the main function, which is sin x. So f of fx is sin x. But there is one more way to write it. This f of fx can also be written as f of fx. F of fx, right? Let's take few more example. You had fx equal to sin x, and we had gx equal to e power x, right? Someone asked you to find the value of f of gx. F of gx. What do I mean by this? F of gx means f of g of x. F of g of x, which means I have to substitute gx inside f. I have to substitute gx inside x, inside f, right? So what is fx? Your fx is sin x. Your fx is sin x. And now in place of x, you will substitute gx. In place of x, you will substitute gx. You will substitute gx. So what do you get? You get f of gx, which can also be written as f of gx, something like this, is nothing but sin of gx. Sin of gx. But what is gx? What is gx? Gx is e power x. Gx is e power x. So your answer becomes f of gx becomes sin of e power x. Sin of e power x. So these type of functions are known as composite functions, right? These type of functions are known as composite functions. I hope you understood. I hope you understood it, right? So very easy and very important, guys. Now, it's not necessary that it will always be f of gx or g of fx or f of fx. It can, I mean, they can elongate that whole thing. They can ask you f of fx, g of fx. Let's take an example. Again, fx is your sin x, your fx is sin x, and your gx is e power x. Your gx is e power x. So how do you do it? How do you do it, right? So guys, let's say someone asks you to find f of g of fx. F of g of fx. How do you find it? So let's understand what is it. Let's understand what is it. It is f of g of fx. Okay. It means you have substituted f inside g. You have substituted f inside g. And then the whole thing is substituted inside f, right? The whole thing g of fx is substituted inside f. How does it work? How does it work? So first of all, guys, we have to find g of fx. We have to find g of fx. So you have gx equal to e power x. You have gx equal to e power x. You will substitute fx inside. You will substitute fx inside, right? So what do you get? You get g of fx. You get g of fx as e power fx. You get it as e power fx. And what is fx? What is fx again? If you see, fx is sin x. Fx is sin x. So g of f of x. G of f of x is e power sine x, e power sine x. But that's not the answer. That's not the final answer. You have to substitute g of fx. You have to substitute g of fx inside f. You have to substitute g of fx inside f. You have to substitute g of fx inside f. So what is fx? Fx is sine x. So fx is sine x, right? And now instead of x, you will substitute g of fx. Instead of x, you will substitute g of fx, right? So what do you get? What do you get? You get f of g of fx equal to sine of g of fx, right? What is g of fx? What is g of fx, guys? G of fx is e power sine x. G of fx is e power sine x. So your answer will be sine of e power sine x. E power sine x, right? So this is what f of g of fx look like. This is what f of g of fx looks like. What do we call these type of functions? We call them as composite functions. We call them as composite functions. We call them as composite functions. Okay. I hope you understood. I hope you understood this. Okay. Now what? I'm going to discuss a very interesting type of function, and I'm sure you're going to love it. I'm sure you're going to love it. Okay. So guys, there is something we call as inverse functions. Okay. There is something we call as inverse function. There's something we call as inverse function. There is something we call as inverse function. What do I mean by inverse function? What do I mean by inverse function? So guys, if you have a function, okay, if you have a function, and if you take the image of that function, with respect to a line y equal to x, then the resulting thing that you get is an inverse function. Right? I'm going to show you that. Let's say you have a function. Let's say this is your y-axis, this is your x-axis, this is your origin. Let's say you have a function like this. Okay. Now draw a line y equal to fx. Draw a line y equal to x, not fx. Sorry, y equal to x. So the image that you will get over here, if this is fx, this is your f inverse of x. Okay. If you want, I can use another color as well. So the black line is fx and the green line is f inverse x. The black line is fx, the green line is not line, curve actually. The green curve is f inverse of x. So I'll write it down. So an inverse function is nothing but image of fx with respect to WRT, with respect to a line y equal to x is known as an inverse function. Inverse function is known as an inverse function. Okay, I hope you understood. Now guys, the thing is, how do we find the inverse function? Okay, the question now that arises is how to find an inverse function. Okay, I think I spelled it wrong yet again. Inverse function. Okay, so if you observed, what I said was it is an image with respect to the line y equal to x. When you take the image, what happens? The y coordinate will become x coordinate and the x coordinate will become y coordinate. Okay, when you are gonna take the image with respect to line y equal to x, what is going to happen? The y coordinate will become the x coordinate, the x coordinate will become y coordinate. Okay, which means the domain will become the range and the range will become the domain. Okay, so let's say you have a function. Okay, how do I find it? I'll just write the steps and then we'll take some examples. Okay, so your first step is swap x and y, right? Now your second step is make y as the subject. Okay, easy. When you do this, you get the inverse function. I'll give you an example. Let's take example number 1. Let's take example number 1. Your example number 1 is y equal to 1 over x minus 4. Y equal to 1 over x minus 4. Step number 1. What is the step number 1? You swap x and y. So x equal to 1 over y minus 4. X equal to 1 over y minus 4. Now you have to make y as the subject. So I'm shifting y minus 4 on the left hand side and I'm shifting x on the right hand side. So y minus 4 will be equal to 1 over x. What happened? What just happened? I substituted this on the left. I substituted this to the right. Okay. So y minus 4 equal to 1 by x. So y will be equal to shift negative 4 on the other side. 1 by x plus 4. 1 by x plus 4. Now take x as the LCM. So you get y equal to 1 plus 4x divided by x. 1 plus 4x divided by x. Okay. So guys, if this is your function fx, then this thing over here is your f inverse x. This is f inverse x. Okay. Now one thing that I want to mention here is that f inverse x is not equal to 1 upon fx. It is not equal to 1 upon fx. Guys, this is very, very important. Please remember, f power minus 1x doesn't mean it is 1 upon fx. It is an inverse function. Okay. So what is 1 upon fx? Always remember, 1 upon fx is fx whole power minus 1. Whole power minus 1. This is 1 upon fx, not the one which is above, right? So I hope you will remember this and you won't make this silly mistake. Okay. Now I'm going to give you one more example. Let's say you have y equal to 2x minus 3 upon x minus 2. How do I find the inverse of this function? Very easy. Swap the variables. So x equal to 2y minus 3 divided by y minus 2. Okay. Now you have to make y as the subject. So let's shift y minus 2 on the left hand side. So y minus 2 times x equal to 2y minus 3. Okay. Now let's simplify. So you get xy minus 2x equal to 2y minus 3. Now I am going to collect the terms including y to the left and the rest of the term on the right. Okay. So I am shifting 2y to the left. I am shifting 2x to the right. So you get xy minus 2y equal to 2x minus 3. Minus 2x goes on the right hand side, becomes plus 2x. Positive 2x, right? Now you can take y common, right? So you get y times x minus 2 equal to 2x minus 3. You get y common. So y times x minus 2 equal to 2x minus 3. So y will be equal to 2x minus 3 divided by x minus 2. Y will be 2x minus 3 divided by x minus 2, right? So this is your inverse function. This thing over here is your inverse function. This is your f inverse x. Now there is one interesting question that I'm going to take and then we'll move on to the next topic. There is a very interesting question that I'm taking right now. Let's say you have y equal to x square minus 4x plus 3 and you have to find the inverse of this function. How do you find it? So you swap the variables. That's your first step. So x equal to y square minus 4 times y plus 3, right? Second step is you have to make y as the subject. So shift x on the other side. So you get y square minus 4y plus 3 minus x equal to 0. So I have shifted x to the right and I rewrote the equation like this. Okay. So even if you write it like 0 equal to y square minus 4y plus 3 minus x, it will be the same thing, right? So I have rewritten the equation. I have changed the arrangement. So this is how it look like. Okay. This is how it looks like. So what happens? Now I have to find the value of y, right? If you observe, you have a quadratic in terms of y. Where a is 1, b is negative 4, and c is 3 minus x. So how do I find the value of y? So y will be equal to negative b plus or minus square root of b square minus 4ac divided by 2a, right? So the thing becomes y equal to negative of negative 4 plus or minus square root of negative 4 whole square minus 4 times a, which is 1, and c, which is 3 minus x, divided by 2 times 1, which is 2. Okay, let's simplify this. So y equal to 4 plus minus square root of minus 4 whole square is 16, then 4 into 1 is 4, into 3 is 12. So this becomes minus 12 because we have a minus sign before 4. And then you multiply minus 4 with minus x, then you multiply minus 4 with minus x. So you get minus 4 minus x plus 4x plus 4x. I hope you got it. I hope you got this, right? So this is divided by 2. This is divided by 2. So y equal to 4 plus or minus 16 minus 4 is 16 minus 12 is 4. So this is 4 plus 4x divided by 2, If I take 4 common, I get 4 plus minus 2 root 4 plus 4x. Oh, sorry, 1 plus x. 1 plus x divided by 2, So I have skipped a step here. What did I skip? I'll show you that. We had root of 4 plus 4x. You can write this as 4 times 1 plus x. Now you have square root of a into b. So it can be written as square root of a into square root of b. So square root of 4 is 2. And then you have 1 plus x. So this is what I've written here. Okay. So I hope you understood. Now if you observe, we have multiple of 2 in both the terms and in the denominator as well. So we can simplify. So this is 2 times 1, this is 2 times 2, this is 2 times 1, right? So the answer becomes y equal to 2 plus or minus square root of 1 plus x. So if you observe, you are getting two answers here. One is 2 plus square root of 1 plus x and one is 2 minus square root of 1 plus x. So does the function exist? If you remember, a few minutes back we saw that in a vertical line test, there should be only one and only one point of intersection. What does that mean? It means that for every value of x, there should be only one value of y. Right? So if you have multiple values, it's not a function. It's not a function. So for the domain, your fx function was x square minus 4x plus 3. Do you have any restriction over here? The domain over here is all real. Don't worry, I'm going to record one more video on domain and range where you will understand what is domain, what is range. So right now I'm writing directly. The domain is all real. All real means minus infinity to plus infinity, right? This is your domain. In the whole domain, the inverse function doesn't exist. You can draw a graph. Okay, you can draw a graph. If you draw it on Desmos, it will look something like this. So for the whole domain, the inverse doesn't exist. How do I know it? Draw a horizontal line. You have more than one point of intersection. If you have more than one point of intersection, then in that case, the inverse doesn't exist. So the way we had vertical line test for confirming if it's a function or not, we have a horizontal line test to confirm if the inverse exists or not. So guys, if I restrict the domain, okay, if I say, let's say, okay, if you do it on Desmos, you will know that this point is going to be 2 comma minus 1. So let's say if I say that my domain is only this much. Okay, if I restrict the domain, if I say only this highlighted part is my graph, the left half is not my graph, then only for the right half, the inverse will exist, right? If I say only the highlighted part is my graph, which means if only this is my graph, then for this graph, the inverse will exist. What will be the inverse? The inverse will be 2 plus root of 1 plus x. Or if I say my graph is only the left half. My graph is only the left half and not the right half. Okay, which means my graph is something like this. Okay, then what will be the inverse? The inverse over here will be 2 minus root of 1 plus x. 2 minus root of 1 plus x. Okay, so either it will be left half or it will be right half. If you are saying the domain is the whole thing, if you are considering this whole graph, then the domain doesn't exist. Then the inverse doesn't exist. Right? So you can restrict the domain. I mean, you can say that, let's say fx is x square minus 4x plus 3, where x belongs to minus 2, not minus 2, positive 2 till infinity. Okay, so I'm talking about the yellow half. Right? I'm talking about the yellow half. So your graph will look something like this. Your graph will look something like this, and the inverse will be this. Right? So you can restrict the domain, and then you can say that the inverse exists. But for the entire domain, for all real values, the inverse doesn't exist. So you have two lines test. You have two tests. Sorry, one is vertical line test. And the other is horizontal line test. Okay. So vertical line test. The vertical line test is to check if fx exists or not. And the horizontal line test is to check if f inverse x exists or not. The horizontal line test tells you if the inverse exists or not, right? So I hope you understood this. This was a very interesting topic. The one thing that you learned from here was, for a function to exist, every x value must have one and only one y value, which means for every input there should be one and only one output. It means it is one-to-one function. What are one-to-one, many-to-one function? Let's say you have a set A, you have a set B, you have some terms A, B, C, you have something called P, Q, R, S. You can have more, you can have less. So for A the value is P, for B the value is, let's say, P again, for C the value is S. If you observe, let's say A is your input, B is your output. For every value of X, for every value of input, there is one and only one output. Okay, there is one. So for A, the output is only P. It is not something else, right? I mean, it can be, okay, let's say if the function looks something like this. This is A, this is B. This is A, B, C, this is P, Q, R, S. Let's say for A the value is P also and Q also. For B the value is, let's say, P. For C the value is S. So if you observe, A is having multiple values, A and P and Q. A is having multiple values, P and Q. So this is not a function. This is a function, right? So if you observe, the mapping is, you have on the input, you have one to many functions. It is one to many function. Why one to many? Because for one output you have multiple outputs. No. I'm sorry. What is one to one? So you have one to many, you have many to one, and you have one to one, many to many. So if you observe over here, A and B have one common output, which is P. So many functions has one output, right? So this mapping is many to one. This function mapping is many to one function. Why many to one? Because A and B are having P as the common output, right? So that's allowed for every input, but necessarily if you see, for every input there is one and only one output. Okay. Now if you observe the second one, A is having two outputs, right? And P has two inputs. So this is many to many. to many function. This is many to many function. This is many to many function. How do I know this? How do I know this? If you observe A has many outputs P and Q, and if you observe from the point of view of B, then P is having many inputs, which is A and B, multiple outputs. So that's why it is many to many function. That's why it is many to many function. You can have a set like this. You can have a set like this, where you have A, B, C, you have P, Q, R, S, where you have A mapped to P, B mapped with R, C mapped with S. Now you have one input, one output. A is mapped with P, B is mapped with R, C is mapped with S. So this is one to one. This is one to one function. Okay. Now there is one more something. I mean, there is something more interesting. Let's say you have a mapping something like this, where you have A, B, C, you have P, Q, R, S, and let's say the mapping is done something like this. Okay. So if you observe set B, S is not mapped with anything. S is not mapped with anything. So we call it into function. And if you observe another example of A, B, and C, and you have P, Q, and R, let's say, where the mapping is something like this. Okay. Now, if you observe every input, every element of set A is mapped with every other element of set B. Every element of set A is mapped with every other element of set B. So we call it as onto function. Because everything is mapped. Okay. So I hope you understood this. Now there is one more interesting type. Which is even or odd function. What do I mean by this? So guys, you have even functions. You have odd functions. Let's differentiate these. So in even function, if you have a function fx, you have a function f of minus x, then f of x will be equal to f of minus x. If this is true, then the function is even function. If this is true, the function is even function. I'll give you an example. Let's say you have a function y equal to x square. Let's say this is fx. What is f of minus x? F of minus x will be minus x whole square. Which is again x square. So if you observe, your fx is same as your f of minus x. So this type of function is an even function. I'll give you one more example. Let's say fx is cos x. What is f of minus x? It will be cos of minus x. Cos of minus x is again cos x. So if you observe, your fx is same as your f of minus x. Which means it is an even function. What is odd function? Let's say you have a function fx, you have a function f of minus x, you have a function fx, you have a function f of minus x. And if f of minus x is equal to negative of fx, then the function is odd function. Or you can say, shift this on the other side, f of minus x plus f of x equal to 0. If this happens, the function is an odd function. I'll give you an example. Let's say fx is x cube. Let's say the function fx is x cube. What will be f of minus x? Instead of x, you replace minus x. So it becomes minus x whole cube, which is minus x cube. So if you observe, fx plus f of minus x will be 0. Fx, x cube, plus minus x cube will be 0, right? X cube plus minus x cube is 0. So this means it is an odd function. I'll give you one more example. Let's say fx is sin x. What is f of minus x? It is sine of negative x. So sine of negative x is negative sine x. Sine of negative x is negative sine x, right? So if you add fx and f of minus x, if you add fx and f of negative x, your answer will be 0. Your answer will be 0, right? So this is an odd function. This is an odd function. Now there is one more interesting thing that you should know. Let's observe the graph of even function y equal to cos x, and let's observe the graph of an odd function y equal to sin x. Okay, so the graph over here, this is x, this is y. The graph of cos x looks something like this. Okay, and the graph of sin x, if you observe the graph of sin x, not that a straight line, but I'll try to draw a better line. Still not straight. Anyway, so this looks like this. Okay, so remember that if you have an even function, the even function is symmetric with respect to the axis y-axis. The even function is symmetric with respect to y-axis. The function looks towards the the function which is towards the right of y-axis is exactly same as the left to the y-axis, right? So if you see, you start from maximum, you go to the minimum. If you see on the left, you start from the maximum, go to the minimum. Then again, from the minimum, you go to the maximum. And towards the left, from the minimum, you go to the maximum, right? So if you observe, the graph is symmetrical. The graph is symmetrical, right? With respect to y-axis. So for even functions, the graph is symmetrical. The graph is symmetrical with respect to y-axis, right? And for the odd functions, what's happening? You start from the origin, you go up towards the left. You start from the origin, you go down, then you go down towards the right, and on the left you're going up. So what is happening? The graph is symmetrical with respect to the origin. So for odd functions, the graph is symmetrical with respect to the origin. Okay, so this was basic difference between these were the basic difference between even and odd functions. I hope you understood it. So that's not all in functions. There are many more things that we have to cover in functions, but for this video I am stopping here. In the next video we'll cover different types of function, for example straight line function, quadratic function, cubic function, rational function, logarithmic, exponential, and many more. Okay, so we'll see those in the next few videos. In this video I'm stopping here. That's it for this class. I hope you understood, I hope you enjoyed, and I hope you learned a lot of things. So do like the video, do share, and do subscribe. Thank you.